Today we're going to have a quick video on function notation and evaluating those functions. Let's say you were given a function, in this case f of x equals x squared plus 2x, and we have a given domain. Our domain only consists of 4 different x values, -2, 0, 2, and 5. If we're asked to find our range, in other words, the y values that coordinate with those given x values, we need to evaluate our function at each number in the domain. So that sounds kind of technical. Let me show you what it's all about. I take those values in my domain, and one at a time, I'm going to plug them in to my function for x. So I'm going to find f of -2, f of 0, f of 2, and f of 5 for my 4 values in my domain. Let's start with f of -2. I'm going to plug in a -2 everywhere I had an x. I'm going to get 4 plus -4, and that gives me 0. Next, I'm going to do the same thing, plugging in a 0 where x used to be. That's going to give me 0 plus 0, and I get an outcome of 0. Next, for f of 2, we're plugging in a 2. That's going to give us 4 plus 4, and we get an outcome of 8. And for my input of 5, that's going to give me 25 plus 10, and I'm going to get an outcome of 35. So why is this important for my inputs and my outputs? Well, those inputs again came from my domain. What I was trying to find was the range. So all those output values, the 0, the 8, and the 35, those are my range values or y values. So I'm going to write them down in a set, remembering to use squiggly brackets, in order, least to greatest, no repeating. So the 2 zeros, I only need to write 1, an 8, and a 35, and that's my range that coordinates with the given domain. Remember, we took each number in the domain, plugged it into my original function for x, evaluated it or solved it, and whatever I got out was the range. Remember that these examples can be rewound and that you're supposed to be writing your examples in your notebook to bring to class. Next, let's talk about using a graph to evaluate a function very quickly. So if I have a graph and I'm asked to evaluate a function at a certain number, this can be faster and easier than anything I've done before. Let's say, for instance, that we were asked to evaluate f of 2. Remember that that 2 is an x value. I'm plugging it in for x. Well, what that means is I want to find the coordinating y value for that 2. So I'm going to go on my graph to where x is 2. If I come over to where x is 2 and come up to my graph, I find the point 2, 4. 2 is my input or my domain number. 4 is its coordinating y value. The 4 is part of my range, and it's also what I'm looking for when I'm asked to find f of 2. So that 4 is hugely important to me so that I can say f of 2 equals 4. What if I was asked to find f of -2? Since I don't have an equation, I just have a graph, I need to remember that that -2 is an x value. When I come up to my graph, I find the point -2, 2. Where -2 is a number in my domain, the +2 is the number in my range. That's also what I'm looking for when it asks me to find f of 2. So f of -2. f of -2 then I can say is equal to 2. How about f of 6? When x is 6, what's my y value? Here's my point. The x value is 6. What's the y value that goes with it? Oh, it's also 6. So f of 6 is equal to 6. One more. How about f of 4? If I come over to where x is 4 and go up to my graph, I find a point. What's its coordinating y value? A 5? So I can say that f of 4 is equal to 5. My function value when x is 4 is equal to 5. Remember to write down some of these examples, and I will see you in class. Have a great day.